Lesson 6.6, Function Operations. For this section, we're going to work with adding, subtracting, multiplying, and dividing functions. To start off with, we're going to take a look at adding and subtracting. So we have these two functions. And to start off with, it wants us to, this is saying the f function plus the g function. And we can have it written like this, or they can distribute it and have it look like this. So we have our f function and we want to add our g function to it. So our f function is 4x plus 7, so we plug that in, and then plus, and then our g function is the square root of x plus x, so we substitute that in. And then from here, for adding and subtracting, we're just combining like terms. So we have 4x plus 1x is 5x, and then 7 and square root of x we're just going to bring down. These are not like terms, so we can't simplify it any further. The follow-up question is going to ask what is the domain. So the two things that you're looking for to figure out what the domain is if there is a square root in the problem or if there's a denominator in your problem. And this one doesn't have a denominator, so we don't have to worry about that, but it does have a square root. We do not want a negative underneath the radical, or we'll have our imaginary numbers. So then we want x to be everything greater than or equal to 0, no negatives. So that would be our domain. Now over here, we're subtracting. For subtraction, we do want to be careful. Order is important for subtraction. So they want us to take the f function and subtract the g function from it. And again, you can have it written either way. So our f function, we're going to substitute that in, and then minus, and then our g function, we're going to substitute that in. Now this one, they're subtracting, so a couple different options that you have. Just remember it's a subtraction problem. So you're subtracting each term after it, or you might want to just put a 1 here and distribute that -1, then you don't have to worry about remembering it when you're combining your like terms. So -1 times the square root of x is negative square root of x, -1 times x is negative x. And then we're going to combine like terms, so 4x minus 1x is 3x, and then the 7 and then the minus square root of x, we're just going to bring those down. None of these are like terms, so we can't simplify it any further. And this one has a square root again, so we don't want any negatives, so just x has to be a positive number, so x is greater than or equal to 0 would be our domain. The next ones we're going to take a look at, we're going to work with two new functions. And to start off with, they want us to take the f function plus the g function. So this f function, 2x squared plus 8, we're going to substitute that in. The g function is x minus 3, so we plug that in. And then for this one, we just combine our like terms. So we bring out our 2x squared, bring down our x, and then 8 minus 3, we bring down our positive 5 when we combine those like terms. None of these are like terms, so we can't reduce it any further. And then this one doesn't have a square root sign, doesn't have a denominator, so then it's just going to be all reals for your domain. All reals just means that any value x could equal. Over here, they want us to take our f function and then subtract our g function from it. So we plug in our f function, plug in our g function. Again, with subtraction, you're going to want to remember to distribute that -1. Addition, it doesn't matter. Distributing a +1, it stays the same. But for this one, then we have 2x squared plus 8 minus x, and then plus 3. So then we have that 2x squared. We bring that down. We have that negative x, so bring that down, and then 8 plus the 3, we end up getting 11. And then from here, that's our final answer. We can't simplify it any further. And then our domain is going to be all reals because there's no denominator and there's no square root symbol. Now let's switch to multiplying and dividing. So these are the two functions that we're going to be using for our multiplying and dividing. So we're going to start with multiplying. This closed circle just means we're multiplying, so they want us to take our f function times our g function. And we can have it written like this, or we can have it written like this, that both of those mean that we're needing to multiply. So our f function, we're going to substitute that in, our g function, we're going to substitute that in. And then for this, you can see that we're going to have to distribute or FOIL. So we're going to distribute the x squared to both of our terms. So x squared times x is x to the third power. X squared times 3 is 3x squared. Now we're going to distribute the negative 9. So negative 9 times x is negative 9x. Negative 9 times 3 is negative 27. We have no like terms, so we cannot reduce it any further. So that is our final answer. And then we have no denominator, no square root symbol. So our domain is just going to be all reals. Alrighty, over here we're going to divide. Again, division, the order is going to be important. So they want the f function divided by the g function. We can have it written like this, or this form over here on the right. So the f function needs to go in the numerator. The g function needs to go in the denominator, so we substitute those in. Now we're going to take a look at, we need to factor these. So in the numerator, this is the difference between two perfect squares. So take the square root of the first term, which is x, that's going to be your first terms. Square root of 9 is 3, so that's going to be your last terms. The middle terms cancel out. There's no x term in the middle, so we need one positive and one negative in order for that to happen. Now if we FOIL this, we'd get back to what we started with. So we have everything factored, and then at this point, if anything is the same on top and bottom in terms of the entire factor, then we can cancel those out. So this x plus 3 is the same in the numerator and the denominator, so we can cancel those out. So our final answer would just be x minus 3. Make sure that you cannot cancel out right from the start before you have it factored. You need a factor first, and then you can cancel if anything is the same. And then to look to see what your domain is, look at the factored form. Now this one has a denominator. We don't want the denominator to equal 0 because we cannot divide by 0. So we're going to set whatever is in the denominator equal to 0, solve for it. We then get x equals negative 3. So our domain is going to be all reals, but x cannot equal negative 3 because negative 3 plus 3 would give us 0. So it's all reals, but x cannot equal negative 3. Alrighty, let's take a look at some more multiplication and division. Okay, so these are our new functions. Let me get it set up again. Okay, to start off with, we're going to multiply. So the f function times the g function. So we substituted in our f function, we plug in our g function. Now we need to multiply these. So I'm going to distribute the 3x to all three of these terms. So then we have 3x times 3x squared is 9x to the third power. 3x times negative 11x is negative 33x squared. 3x times negative 4 is negative 12x. Now I'm going to distribute this 1 to all three terms. So 1 times 3x squared is 3x squared. 1 times negative 11x is negative 11x. 1 times negative 4 is negative 4. Now at this point, any like terms, I want to go ahead and combine them. So I bring down that 9x to the third power. Negative 33x squared plus 3x squared is negative 30x squared. Negative 12x minus 11x is negative 23x, and then we bring down our minus 4. This one has no square root, it has no denominator, so our domain is just all reals. Over here we're going to use the same two functions, but we're going to divide. So our f function is on top, the g function is on bottom, so we substitute those in. Don't think about canceling yet, we need to factor both the numerator and the denominator. So then we're going to take our 3 times our negative 4, we get negative 12, and then we're looking to see what multiplies to negative 12 but adds up to that middle term, negative 11. So we have 1 and 12, 2 and 6, 3 and 4. The combination would have to be 1 and 12. The 12 would be negative, the 1 positive, and then we have to do our grouping. So we leave for the first term alone. Then we replace the middle term with 1x and minus 12x minus 4, and then we do our grouping. Group the first two terms, group the last two terms. And x goes into both of the first two terms, so we factor that out. We have 3x plus 1 left over. A negative 3 goes, or negative 4, sorry, goes into both of those terms. So we factor that out, and then we have 3x plus 1 left over. But notice what's in parentheses is the same. So that's the one set of parentheses, 3x plus 1. And then what's on the outside, the x minus 4, is the other set of parentheses. So we have the numerator factored. The 3x plus 1 in the denominator can't factor, so we just leave that. And then now that it is factored, we can simplify it by canceling out what is the same. And then this x minus 4 is left over, so that is our final answer. And then when we look in factored form, whatever is in the denominator, we're going to set equal to 0. We're going to solve for it. So we get 3x equals negative 1, divide by 3. So we get x equals negative 1/3. So our domain is going to be all reals, but x cannot equal negative 1/3. And again, the reasoning would be if x did equal negative 1/3, if we plug that into the denominator, we get 0, and we cannot divide by 0. The last topic that we're going to cover in this section is composition, so composing functions. So we have these two functions that we're going to be taking a look at. To start off with, it wants us to take g of f of negative 3. And they can have it written down like this or like this. Notice it's an open circle, not a closed circle, meaning multiplication. So when we see this open circle, it means composition. So how this works is you start with the number and you work your way out. So it's saying x equals negative 3, and we need to plug that into our f function. So we go to our f function, we're going to plug in negative 3. So negative 3 minus 5 is negative 8. Okay, now using that negative 8, we're now going to ignore the negative 3. We're now using the negative 8, and we keep plugging that, working our way out. So now x equals negative 8. We're now going to plug that into our g function. So negative 8 squared. So negative 8 times negative 8 is positive 64. So now we have 64. Notice we have nothing else to plug it back into. So then 64 is our final answer. Alrighty. Now this one, again, we start with the number. We work our way outwards. So it's saying x equals negative 3. But now we plug it into the g function first. So we go to the g function, negative 3 squared, we get 9. So now we have x equals 9, and then we're going to plug that into our f function. So we go to our f function, we plug in 9, 9 minus 5, we get 4. So then 4 is our final answer. Notice for these problems, I used the exact same two functions, but I plugged this one on the left into the f function first, then the g function. Over here on the right, I plugged it into the g function, then the f function. So notice I get two different answers, so the order is going to be important on composition. And for these ones, we're not going to be listing the domain. Alrighty.